So, good afternoon students. In the previous section we have missed this live class recording from this strong acids, weak acid, strong base and weak base. So, here we come across this strong acid, weak acid, strong base, weak base. So, we are differentiating the strong acid, weak acid, strong base and weak base. How? That is on basis of their completely ionization. So, if any compound is being ionized, then you can say them as strong acid. Yes or no? If any compound is being incompletely ionized, then you can say them as base. And if they are having somewhat incomplete ionization, means you can say them as weak acids. Okay, you can say them as weak acids. So this weak is because of incomplete in their ionization, So whereas strong acid means there is completely ionization. So here you came across these examples. What are the examples? HCl, H2SO4. And then next coming to weak acid means H2CO3, CH3COOH. And this is excuse me, H2CO3, CH3COOH and strong base, weak bases and all. So if you take this strong base as an example, this is completely ionized, and if you take an weak base, that is incompletely ionized, that is nothing but NH4OH and AlOH taken thrice. So these are very much important examples. Okay, they are very much important example. That is HCl is a very strong, and H2CO3, acetic acid, weak acids. Strong base means NaOH, NH4OH means weak bases. So all these examples are much important. Okay, so remember these examples in your chapter. In this chapter you have to learn these examples. And if you take this NaOH, this is from this first group elements. What is that? First group element is nothing but Na and OH minus. What is that Na? That is first group element potassium, rubidium, cesium and francium. So all these are first group elements. They are on reaction with OH minus. They gives you an example, that is completely ionized NaOH. At the same time, this is you are having 17th group element fluorine, chlorine, bromine, iodine and astatine. So these elements are just near to 18th group element. They are just near to 18th group element. If they get one electron, they becomes very stable. Yes or no? If they get one electron, so this is a periodic table. If you take, this is nothing but an 18th group element. This is 18th group element. This is having a very configurated filled orbital. Here is 17th group element. These 17th group elements are nothing but fluorine, chlorine, bromine, iodine and astatine. If they get one electron, they get some configuration of 18th group element. After getting a configuration of 18th group element, how does they stay? They stay in stable form. You should remember them. Okay. So these are first group elements, and if they lose one electron, they will get a after configuration of 18th group element. So that only this Na is dividing as Na plus OH minus. And this by losing an one electron, they comes as 18th group element. Okay. So next one is, if you take, next thing is indicators. Okay. So we have discussed this what you can say acid, bases, strong acid, weak acid, but how you are going to indicate them? So how you are going to indicate them means, if you see in your naked eye, with your naked eye, some color change will be there. So when you see these color changes, then you can say some change is being happening, means that could be acids or an base. You have to know it. by seeing this indicator name itself says as it indicates. Okay, what does this says? This indicates. Okay, this is an indicator of whether it is acids or base. So this says whether this acid or a base. How does it indicate? They are having their own mechanism, yes or no? If you take an beaker, now fill this beaker with a X compound. Okay, now after filling that beaker with an X compound, you are adding an indicator. Okay, so now take an beaker. If this beaker is being filled with an acid or an base, okay, take that acid or an base as an X compound. Okay, you are taking an beaker, it has been filled with a compound that is nothing but an X compound. So if that X compound is being reacted with an indicator, it is reacted with an indicator, what does it happen? If that is reacted with an indicator, there will be some color change. So you should always remember that if any compound is having some properties, like if you take an X compound, if you add an indicator, that indicates whether it is acid or whether it is base or whether it is not both of them. Okay, take for example now water. Water is something colorless. These colorless compound or this water, or take an example HCl, this is also something colorless. Now when it is added with an indicator, it changes to yellow. Okay, this indicates that is color change. So one most important point you have to remember is indicator is nothing but it changes and color. By changing its color, we can say them as whether it is bases or acids. Okay, that indicators are of how many types? They are of 4 types. So what are they? They are natural indicators, and olfactory indicators, synthetic indicators, universal indicators. What are they? First thing is, you have to remember, first thing is natural indicators, second thing is olfactory indicators, third thing is synthetic indicators, and the last one is universal indicators. What are them? These 4 types are very important. These 4 types are very important and they have their own mechanism and characteristics to indicate whether it is acid or an base. Okay, so these indicators are used to determine whether it is acid or base or none of them. So first one, if you come across this acid, so that is nothing but, take an example, a natural indicator. Okay, this is nothing but, first one is, what is first type? It is natural indicator. So this natural indicator name itself says us that we are getting from nature, yes or no? That we are getting from nature. So these natural indicators are examples like, these indicators are hibiscus, we can call it as China rose. Okay, this hibiscus is nothing but, it is something like this. Okay, so hibiscus, if you take an example, hibiscus will be like this. Okay, mostly hibiscus will be in red. So these are nothing but its pollen grains. Okay, so this hibiscus is also called as China rose. Hibiscus is also called as China rose. And this hibiscus, you can say it as China rose. This indicates whether it is acids or bases or salts like that. Okay. So take a lemon, cut it with a knife which has been rubbed with this hibiscus, then you can get as red color there. That means you can say that lemon is an acid. What acid it is having? It is having citric acid. So this is the small experiment which we have done in our childhoods, that is cutting that knife with this lemon, you are going to get like blood color only. Don't shock with that because it is acid. That is mainly because of acid. Mostly such indicators which we see in your day-to-day life, these are being used by magicians and all to confuse the public. Okay. Next indicator which we get from nature is nothing but red cabbage. This is another indicator which we get from natural only. This we are getting from nature. By nature provided gift. What they are? Hibiscus, red cabbage, and next is litmus paper. What is this litmus paper means? Litmus paper we are getting from lichens. What is this lichen means? This is an bacteria which will be there in the environment. Okay, this will be present in our environment, and these lichens are very useful for our chemical properties, okay, chemical reactions. So these lichens, from these lichens we are going to extract litmus paper. So how does that litmus paper work? Take this litmus paper, this we are getting from where? This we are getting from natural indicators. These are nothing but natural indicators. If you take a base, that with red litmus paper, if you take red color changes to blue color, then you can say them as base. If any litmus paper that is blue in color which is changed to red, then you can say them as acids. These lichens are nothing but these are natural indicators. Why natural indicators? Lichens are the organisms which we get from nature. So that only they are called as natural indicators, and this litmus paper what we get, that is from lichens only. So that lichens, from that we are getting litmus paper. That litmus paper we are using as an indicator. So that only you can say them as natural indicators. Understood this point? And next one, coming to this, oil factory indicators. Okay. Next one is oil factory indicators. If any indicator is being reacted with, whether it is base or an acid, then it indicates some type of smell. Okay. But we are going to detect them by using the smells only. If we get smell, then they are called as oil factory indicators. If you are getting any type of smell, then you can say them as whether it is acids or an bases. That point you have to remember daily. Okay. So for example, we are taking as an onion, we are going to keep it in a bag. Yes or no? Then what we are going to do? We are going to cut it down in a slices, and then we are going to put in a polythene bag with a covers. Okay. Then we are reacting with whether it is acids or a base. Then if we react, it will get smell, and if again it is being added with base, it does what reaction? Neutralization reaction, and will not get any smell. So this oil factory means this is a type of smell based indicators. What I can say? Smell based indicators. So if any indicator we are going to recognize with our nose, with our olfactory substances which are present in our nose by smell, then we can say them as olfactory indicators. That is nothing but, for example, you can take onion as an example. Remember this point. Okay. Then next is coming to, after this we are going to discuss what are synthetic indicators. Yes or no? Next we are discussing what are these synthetic indicators. Synthetic indicators means generally we get any indicators from nature, but these naturally products we are going to react with them in a chemical laboratories. In chemical laboratories we are going to make these synthetic indicators. If we produce any compounds in laboratories, then you can say that indicators are synthetic indicators. Synthetic indicators means they are being produced in a laboratory with our own mechanical chemical formulas. These indicators are like phenolphthalein and methyl orange. Okay, this phenolphthalein and methyl orange, these both are nothing but they are chemically produced in laboratories. Okay, these are being chemically produced in the laboratories, so they are called as these synthetic indicators. Synthetic indicators. This point you have to remember. What is the point you have to remember? Most point is, if any compound we are getting from nature, and from that nature we are going to make them in a chemical based formula by reacting, taking a test tube, adding, by titrating and all, by that mechanical and physical processes we are producing this phenolphthalein. Mostly phenolphthalein indicators are synthetic indicators and methyl orange indicator. This is also another example of what I can say synthetic indicators. Okay. Yes. Next, coming to universal indicators. Universal indicator means all the indicators which we use, they are universally recognized. So no, universal indicators. So you should mostly remember all these things. They are nothing but litmus paper, what you can take, and methyl orange type, and hibiscus natural indicators. So all this comes under what you can say is their pH ranges from 1 to 14 are called as universal indicators. So this point you have to remember in your exams also. So synthetic indicators means you are learning about two examples. They are nothing but phenolphthalein as an example, and next is methyl orange. Phenolphthalein and methyl orange. So next is oil factory indicators, which we can recognize with our nose. So we are recognizing them as smells and all. So by taking that smell as an basic point to this, we are adding as oil factory indicators. And next is litmus paper, what we take, that is from natural processes or no. That litmus paper we are taking them, that is a natural thing which we are getting from nature. That litmus paper is also an indicator, that you have to remember. Okay. Next one is, next topic what we are going to discuss is mixing of acid bases with water. Okay. So generally, first point what you have to remember is mostly, generally if you take HCl is an strong acid. HCl is an strong acid I am saying, but dry HCl if you take, dry means like crystallized form like this. If you take dry HCl, this is not an acid. Why? So when it coming to this acid, HCl is a strong acid I am saying, but whereas dry HCl is not an acid I am saying. Why? Because in the past things, we by closing our eyes, we have learned that if any acid it is giving H plus ion, then I can say it is acid. If anything, any compound is accepting is electron acceptor, then you can say it as an acid. And if by Arrhenius theory and Lewis theory we have learned those things. And if any compound is being completely ionized, then you can say them as strong acid. If they are not completely ionized, then you can say weak acids. But the thing here is, I am saying this HCl in the dried form is not an acid. Why? That is because it does not gives H plus ions. So when these acids are being mixed with this water, aqueous form only, they are acidic. Okay. So when this acid is in aqueous form, if taken bigger, this should be in a aqueous form, not in a dried form, then you can say them as strong acid. They are acid, you are saying. Mixing of this acid bases with water, that means dryly containing compounds, like dry compounds are not acids. Why? They are not releasing any H plus ion, they doesn't gives you any H plus ion. Dry acid will not give you any H plus ion. Whereas this HCl, when compared to this aqueous solution, they gives you H plus ion outside. So when it gives H plus ion, we can say them as completely ionized, or they are being ionizing in aqueous form only. Now if you take an example for another example, that is nothing but, you can take next one is CH3COOH. What is this? Acetic acid. So this acetic acid in aqueous form only, weak acid. Acetic acid in aqueous form only, weak acid. Okay. Acetic acid in aqueous form only, weak acid, not in dried form. Okay. Taking for example this HCl and dry HCl. Why these are not an acids only? Because of they are not giving you any hydrogen ion. If they gives you hydrogen ion, then they are acids, you can say. These acids are having H plus ion and ionization. If they are ionizing has an H plus ion and OH minus ion, then you can say them as acids and bases. But if they are not ionizing, you should not say them as acids. So by mixture of this we can understand that these are the types of acids and bases which are weak acid and strong acid. Yes or no? So next thing what we are going to learn is pH scale. So to determine any compound, okay, to determine any compound or a strength of an acid, what is that? Strength of an acid. We are going to use some scales, okay. So to determine your, like you can say your, if you are going to gym, you are going to measure in terms of muscle, bicep, tricep and all. And if you are going to any competition, if you measure any height, you are going to measure them in terms of centimeter, feet and all. So in this way we are going to measure strength of an acids, okay. Strength of an acid and strength of an base by taking a scale. That is, this is the measurement scale. This is nothing but represented as pH, okay. What is this P stands for? What is this P stand for is potence. Okay. What is this P stand for is potence. It is been introduced by a scientist called Sorensen. Okay. It is been introduced by a scientist called Sorensen. So this point you have to remember, okay. So as I said you, we are going to discuss this pH scale. If you go to gym, they will measure your bicep, tricep and all. They will determine how much strength you are. And if you go to any competition like sports competition or any some jobs and all, they will measure your height in terms of centimeter, feet and all. In this way they will measure the strength of an character. In the same way we are measuring the strength of an character of a chemical substance by this pH, how much acidic it is. If it is strong acid, if strong acid gets into our body or it falls in our skin, it is very deadliest thing that our skin burns very fast. That fastness is only because we are going to determine their fastness in crime cases like 1 degree, 2 degree burn, 3 degree burn, like this. Okay, this is nothing but a strength, how much strength of an acid being poured on a person, like that. So this scale, measure of this acidic scale is nothing but pH of the acid. What does here P stands for? P stands for potence of an acid. This potence P is nothing but, this pH scale is introduced by a scientist called Sorensen. Okay, understood? So next one is this we are having this units as, taking these units from 0 to 7 and 7 to 14. Okay, these are the units what you can say, that is pH transfer. So if any acid is having this if that ranges are between 0 to 7, you can say them as acid. By closing your eyes, if any pH scale value is between 2, 3, 4, 5, 6, acid. By closing your eyes, if you say that if any acid that pH scale ranges from 1 to 3, strong acid. If the pH scale is ranging from 5, 6, 7, weak acid. 7, 6.9 if you take 6.9. 6.9 is also acid, but mostly it has some fluctuations because it is very near to 7 and basic character. So if any compound is having a ranges from 7 to 14, if any compound is having ranges from 7 to 14, then you can say them as bases. Okay, if any compound is having ranges from base that is 7 to 14, you can say them as bases. Okay, if a compound is having 8, 9, 10 like this, if a compound is having pH scale of 8, 9, 10, then by closing your eyes you can say that it is very strong base. If a compound is having that is 14, that is somewhat weak base. This 7, what does this 7 mean, sir? 7 you are not saying whether it is acid or whether it is base. Then what is that 7 means, sir? Means I can say that 7 is nothing but neutral compounds. What is that? Neutral compounds you can say. This pH scale is very much important in your examinations. Okay, how it is important? That is, very most questions are being asked from this. If pH range is between this to this, what does it stands? It comes under. So if the pH range is between 7, if 0 to 7, then what it is? If it is only 7, then what it is? That means only 7 means you can say them as what compounds? That is nothing but neutral compounds. What the compounds are? Neutral compounds. They are not acidic, not the base, like that. So if the ranges are between 0 to 7, then you can say them as acid, and if the range is between 7 to 14, say them as bases. So in terms of mathematical terms, okay, you can say pH scale is nothing but, what is that pH scale is? pH scale is nothing but negative logarithm of H plus. Okay, what is pH stands for in mathematical terms means, that is negative logarithm of H plus. What is that negative logarithm of H plus means? You are having H plus ions from, you can say, like you are having 10 H plus ion, you think. Then you can substitute here negative log of 10. So log 10 means it is 1. Okay, like this. So you are going to solve problems in such way, but problems are in your standard, I think not much important, but with your standard I can say that pH is equal to negative logarithm of H plus ions. This is nothing but pH scale. Okay, now can we can discuss some pH what we have discussed in the earlier, yes or no? If you are having 5.5 pH, this is the pH of aired rains, okay? And if you are having pH of 7.4, okay, this is blood pH. Okay, next example is taking an example, if the pH is 5.6, then it is the pH of rainwater. So these points you have to remember, that is, if the pH is 5.5, then it is aerated water, and then next is, if the pH is having 7.4, you can say that is the pH of blood which is in our body, and if the pH is 5.6, then it is the pH of rainwaters. Okay, this pH value indicates that how much strength it is having, whether it is acid or bases or salts. Okay, that we are going to determine acids and bases. Okay, next thing what we are going to study is, yes, next one is neutralization of reactions. So what does this neutralization of reaction means? Okay, neutralization, name itself says that it is neutralizing the effect. It is neutralizing the effect. That means take any compound, if it is burning very much, you are adding something, it neutralizes. Okay, that is nothing but neutralization of reaction, you can say. So now neutralization of reaction means, take acid plus base. If you add acid with base, so if you add strong acid, so now you are adding some strong acid with base, then what does it going to form? It is going to form water, salt plus water. Okay, this is nothing but an reaction between a neutralization reaction. Okay, take for an example, H2SO4 plus 2NaOH gives rise to what? Salt. That means you can say Na2SO4 plus 2H2O. If any acid will have some burning character and base. If you are feeling some what you can say acidic in your stomach, then they will give you a base which neutralizes this acid and gives you salt cum water. Okay, these acids are, if you take an example, H2SO4, this is what? This is inorganic strong acid. Okay, a very strong acid. This is nothing but king of chemicals, you can say, king of chemicals. So it is very strong. So if this acid is very strong, how you are going to neutralize its effect? So you cannot take into your hand and you cannot react it. Then what you are going to do? If you are taking an acid, you should neutralize it. You should neutralize its effect. That means you are taking another base. You are adding that acid with you are adding some base. What happens? This acid, when you are adding with NaOH, then you are going to get Na2SO4 2H2O. Yes or no? That is nothing but an salt content and an water content. Take for an example, you are adding HCl as an acid, NaOH as an base. This is very acidic. Acidic means you cannot hold in your hand, you cannot do experiments. So to perform the experiments and to perform your what you can say a chemical formula or reaction, what you are going to do? You are going to add acid with some NaOH, this is base. You are having acid, you are taking base, that means you are reacting. Then what happened? Neutralization reaction taking place, giving you salt, NaCl plus H2O. Yes or no? So this is acid base reaction. This is nothing but these are called as neutralization reaction. Neutralization reaction, that is taking H2SO4. This is inorganic acid, this is something organic acid which we use in our laboratories. HCl is being reacted with NaOH, giving rise to NaCl plus H2O. We are going to neutralize this effect, acid, it is very burning. Then how we are going to neutralize this? Take some base, add some base, you are going to neutralize the character. That means you are going to get, after all, you are going to get some salt in the bottom and you are going to get water also as a byproduct, you can say. Then this acidic and basic neutralization reaction are called as this acid base neutralization reaction, where we are going to get some salt and some water. These are very much important reactions in our day-to-day life. And how these acids are going to react with metal oxides, okay. Acids reaction with metal oxide. Okay. So what are metals? If you take this periodic table, in this we are finding these metals, okay. Magnesium type, copper, all this, okay. This magnesium or copper, if you take an example, if this copper is being added with oxide and this metal oxide, what is this combination called? Metal with oxide, it is called as metal oxide. So what these are? Metal oxide, on combination we can say them as metal oxide. These metal oxide are going to react with what? It is going to react with acid. Acid reaction, acid means this HCl. Acid reaction with what? Metal. Metals are from this first and second group element, metal, copper. This copper is being reacted with what? Oxide. Then with copper with oxide in the presence of HCl, what you are going to get is CuCl2 plus H2O. What is this H2O? As in water. This is nothing but salt, you can say. Okay. So thing here is you have to remember, that is when an acid is nothing but HCl. When an metal is nothing but first group, second group elements. Oxides are nothing but this oxide. When this metal oxide is going to react with HCl, it is going to form salt plus water. So why they are forming in this way only? Yes or no, you can say. Copper, you take copper. So if you take that copper, scandium, titanium, vanadium, chromium, manganese. So like these elements will be there up to 30. Yes or no? These elements are most important. You have to learn 1 to 30 elements very carefully. Okay. Oh, sorry. You have to learn these 30 elements. These 30 elements are most important. Otherwise you will not understand some basic reactions also. If you remember this 1 to 30 elements, that is starting from hydrogen to here neon, and starting from again sodium to here calcium, starting from scandium to here zinc. So all this 10. Without knowing these 30 elements, you are not going to understand any reaction. Okay. Learn these 30 elements, by heart these 30 elements, so that only you can understand what reaction is actually going. how reaction is going. So now I said you before 18th group elements are here, yes or no? So they are having 17th group elements here, yes or no? Chlorine is from 17th group. So when it is from 17th group, it will, if it gets one electron, it gets a configuration of 18. Then when copper is having a configuration of, so zinc, copper and zinc, that means 29. So when this copper is being reacted with this Cl molecules, these two Cl molecules will react to copper form +2, okay. These +2 atom are going to get as Cu +2, okay. This chlorine on combination with copper, this chlorine gets 2 Cl plus ion, yes or no? This chlorine gets 2, one chlorine get 1, another chlorine get 1 electron, then what happens? It gets a configuration of 18th. When it gets a configuration of 18, then it becomes stable. In the same way, oxygen, if you take, oxygen is something here, yes or no? 8th electronic configuration is oxygen. When this oxygen gets 2 electrons, it gets a configuration of neon. Oxygen is here. When it gets a 2 electron with 18th group, it gets a configuration of neon. When it gets a configuration of neon, it is very stable. So this oxygen takes 2 electron from this hydrogen. Understanding the points or not? Yes. So when you get this oxygen as 2 electrons from this hydrogen, you are getting it stable, and these 2 electrons gives oxygen an octet configuration, that is nothing but 18th group configuration, and this is forming as H2O as in water. So these points you have to remember very much. When reaction is going on, you should learn the reaction in terms of this only. So you should take it in periodic table, how it is forming, what are the electronic configuration, how it is going to react, after reacting how much electrons it is going to get, if it gets in that much electron, if it is stable or not, for acting as stable how much configuration it should get, all these things you have to learn. By seeing a normal chemical reactions also, you should learn these examples, okay. In before reactions we have studied this NaCl as an salt. Now if you take that NaCl, now you see here Na plus Cl minus, yes or no? Na plus Cl minus means Na stands here. If it get 1 electron lost, then it gets configuration of 18th configuration, yes or no? When Cl minus gets 1 electron, it gets a configuration of 18th, so that only the here bond between them forms and they forms as NaCl molecule. Here we know how hydrogen is going to form as an H2O, yes or no? So these are very basic rule you have to remember. And next one is we are discussing about acid reaction with metal oxide, and then next is reaction of non-metals with bases. Non-metal with bases, yes or no? This non-metal with bases means, if you take an example, CaOH taken twice plus, this is oxide, this is nothing but non-metal oxide, this is giving rise to CaCO3 plus H2O. Understood this point? Yes. So now this example says that if a non-metal like bases, if a non-metal, what is non-metal means? Which is not a metalloid, non-metallic character. That non-metal means this is a non-metal. CO2 is in the form of gaseous, not in metallic form. Okay. When this non-metal is going to react with calcium and an hydroxide, calcium is a metal. Metal is calcium, this one with OH. This one is OH going to form a base. This basic reaction reacts with CO2. This base on reaction with CO2 gives rise to CaCO3 plus H2O. So this is the combination you have to learn, okay. H2O and CaCO3. This is non-metal with bases. This is an non-metal reaction with, this is a non-metal reaction with, this is a base. Okay, this is CO2 as an non-metal reacting with base. Okay, so got this point? Acids, how we are reacting with, how they are reacting with metal, and at the same time non-metals like bases. When base is reacted with the non-metal, what it is going to form? CaCO3 plus H2O it is going to form. All these reactions also you have to learn very carefully and write down in your notes. Okay. So next thing we have learned acids, yes or no, bases, and now we are going to learn what are salts. So salts, nothing there much to learn in your classes, that is simply we can say salts are nothing but it is a common salt which we take, common salt. So if you provide any dish, so if dish is being produced without salt, okay, if you are not adding salt to the dish, that means any curry or anything you made, if you are not adding any salt to that, that means that dish is somewhat untasty only. Okay, so taste will be something very bad. So to add the taste, we are adding this common salt. This common salt is nothing but NaCl. This common salt is nothing but NaCl. Na plus Cl minus molecules. Na plus Cl minus molecules. So in going on chapters, I will not discuss in this much depth. You should understand here itself. Okay, how it is forming a bond between them, how electrons are being loosed. Common salt we can get from sea water. Yes or no? Common salt we can get from where? Sea water, by the process called evaporation. By this process we can get salt. The salt which we are getting, it is in brown color. Brown color firstly, before purifying. Before purifying, its color will be in brown color. This brown color is due to why? It is due to presence of impurities. It is due to presence of impurities. Yes or no? These impurities are nothing but MgCl2, CaCl2. These pure salts, how we are going to get this pure salt is on passing of HCl gas. If you take an impurity, impured salt, if you pass some hydrogen gas through it, so like this, then you are going to get some crystals. They are nothing but salts. Okay, so salts mostly we can get it from sea water. Mostly sea water contains how much is 2.7 to 2.9% of salt. So mostly sea is containing of sea saline salt, but what we use common salt is that is nearly of 2.7 to 2.9. Okay, so this we are going to get from a method called evaporation. Before we get our common salt which we use in our day-to-day life, that is before that we are going to get it in the form of brown salt. That brown salt we are going to purify it by adding some HCl, passing some HCl gases. Then that brown salt is only because of impurities it is having. That color is only because of impurities it is having, that is MgCl2 and CaCl2. And passing HCl gas we can produce this what you can say salts. Okay, and next, what are the uses of these salts? Okay, we can write these uses here. So it is used in our day-to-day life, yes or no? And next is it is used for pickling. Okay, what is pickling means? You add pickle, yes or no? You take pickle in your summer, that is mango pickle you take. So these are the pieces. If you take mango pickle, you are adding some salt. Why you are adding salt? Why? Salt is having some characteristics which kills bacteria and fungi and microorganisms, what you can say. It is killing microorganisms by having some mechanisms, that is a hypertonic solution, you can say. It creates hypertonic solution to the bacteria that kills its cell wall and breakdown of cell takes place. Okay, that is it creating hypertonic solution. That means this is very saline. You cannot stay in saline water for more time and you cannot drink it also. That is, it kills our organisms parts also. So this salinity, this salt which is mostly added kills bacteria and microorganisms. Yes or no? And then next is pickling and day to day life, and next thing is it is used for preparation of NaOH and many compounds like which are Na2CO3 and all. And these salts are being used to prepare what? NaOH, because Na is present. That Na is we are getting from NaCl only. This Na2CO3, this Na we are getting from NaCl only. CaCO3, this Ca is also a salt. This also we are getting from that NaCl, that is CaCl also. Okay, these are the uses of salts. What are these? Uses of salts. These are very much important, you have to learn. Okay, what are the uses of salt, why it is being used? So we are adding to the pickles to preserve it for many days, to not spoil pickle should not be spoiled from bacteria and fungus, yes or no, like microorganisms. Okay, then we are going to discuss another topic, that is the caustic soda. So some NaOH products, okay, what is this? Base. This basic reaction, this base having many reactions, okay. These reactions are nothing but, you can say, caustic soda. First thing, the first base prepared is caustic soda. Yeah, you can write it. So take a gap, and next one is CaCl2. CaOCl2. This is nothing but and bleaching powder, you can say, okay. And next one is what you can say, next one is NaHCO3. Okay, what is this? This is nothing but a common name of that is sodium hydrogen carbonate, what you can say, baking soda. And next comparative study of them is washing soda, Na2CO3. Okay? Yes. So NaOH is nothing but, NaOH means it is commonly named as caustic soda. Okay? In the same way, CaOCl2 is named as bleaching powder. Well, what these are? These are nothing but common names of these things. Okay? Na2CO3, washing soda. Okay? So next coming to there, what you can say next is how they are being prepared. Okay? So they are being prepared from what? Chloroalkaline metal, that is, this is a method which where we produce NaOH. NaOH is named as caustic soda, and this caustic soda is nothing but a preparative method of NaCl, aqueous NaCl. What is this aqueous NaCl means? This is a brine solution. You can say it as brine solution. Okay. Here I will write. This NaCl plus and water. NaCl plus water gives rise to NaOH plus what? Cl2 plus H2. Okay. What is this? It is reacting as Cl2, H2 and NaCl. This is nothing but an preparative method. Preparation of caustic soda, you can say. Okay. This is nothing but chloralkali type of reactions where NaCl is being reacted with H2O giving rise to NaOH plus Cl2 plus H2. Yes or no? And this is nothing but alkaline preparative method where you can say this is due to hydroscopic, it is having hydroscopic nature also, NaOH. And uses, if you think about uses, what are the uses of it is, H2 is being, this H2 gas which is being used for preparation of what you can say margarines. This is a one point. And NaOH, it is used in, so NaOH it is used in laboratories as an basis. Yes or no? NaOH is used in laboratories, that is it acts as base. So we have learned neutralization reaction. Yes or no? That neutralization reaction are being neutralized by using this NaOH. And next coming to this bleaching powder. This bleaching powder, if you take this, so it's having its what you can say this hybridization in this way. Okay, OCl. So Ca is being bonded. This Ca, if it loses 2 electrons, it gets a configuration of argon. And when it is losing 2 electrons, it gets a configuration of argon. And this Ca plus 2 gives rise to, this is giving 1 electron to chlorine and 1 electron to oxygen and forming as CaCl, CaOCl. And this preparative method, if you take, this is being prepared by CaOH taken twice plus Cl2 gives rise to CaOCl2 plus and water. What is this? Water. So it is an bleaching powder. What it is being used? So it is being formed from where? CaOH taken twice. What is this? Base. Base is being reacted with chlorine to form CaOCl2 H2O as an water. All these are NaOH products only. All these are basic products. All these are bases. And uses of this. This is being used in bleaching of clothes, textile industries. It is being used by bleaching powder by GHMC fellows, by GHMC members, and this bleaching powder is acting as antioxidants. It is also used in detergents. And this NaOH is used in making of soaps. Base, as it is base, it is used in making of soaps. Okay. So whereas coming to this bleaching powder, what we can say common name, commonly named as bleaching powder means CaCl, CaOCl, and this CaOH taken twice plus Cl2 gives rise to CaOCl2 plus H2O. CaO plus Cl2. From this one H2O is taken out. That's it. The reaction is simple. And this bleaching powder is used for cloths. Okay, bleaching powder is used in cloth industries and all textile industries. Bleaching powder is also used by GHMC workers, and that is it is acting as antioxidants, and it is nothing but it is used in detergent agent, like detergent agents. Okay. And next is coming to baking soda. How we can produce this baking soda is, take first some molecules of NaCl. What is this NaCl? This is a salt on addition with water plus some CO2 gas plus add some NH3 molecules. Okay. So understanding this reaction, reaction is nothing but it is a reaction of NaCl salt and water and some CO2 gas, and with that take some NH3, then what you are going to get is NH4Cl plus NaHCO3. Understood? This is nothing but it is baking soda. Okay. This, to produce this baking soda we are using NaCl, H2O, CO2 and NH3. We are using common salt with water with gas with ammonia. Why we are using this NH3? To get NH4Cl we are using this NH3 to react with chlorine molecule. This NH4Cl is reacting with this chlorine. This Na is being bonded, generally it bond with NaCl only. So to unbond with this thing we are going to bond with them with NaHCO3. So this reaction says that NaCl plus H2O plus CO2 plus NH3 gives rise to NH4 plus Cl plus NaHCO3. So this is nothing but preparation methods of baking soda. Yes or no? Next is baking soda on heating. On heating what you can get? So if you heat NaHCO3, yes or no? On heating this NaHCO3 you are going to get Na2CO3 plus CO2 plus water. So what are its uses? So you can say NaHCO3, what is this? Baking soda. This baking soda on heating what happens? On heating what happens? Na2CO3 is you are getting, okay. So you are going to get this Na2CO3. That Na2CO3 is nothing but this washing soda only. Yes or no? So from this only you are going to produce washing soda. That you have to remember. Next one is, if you take these uses, what are the uses of baking soda? Baking soda is used as an soda acids. It is used as soda acids and it is been used as mild antiseptic. Just a light mild antiseptic, and baking soda is used in the form of mild edible acids. Mild edible acid, that is nothing but tartaric acid. Tartaric acid. So all these points you have to remember. You have to remember NaOH, common name, preparation method called preparation, how it is going to prepare. Then H2, what are the uses? Then NaOH being used as laboratories in as a base, making of soap. All these are uses. Okay, all these are uses. So this uses also important. Okay, this what you can say, bleaching powder is used in bleaching the cloths, and also bleaching powder used by GHMC members. Okay, and it is used in textile industries. It is used as detergents, like this. So all these points you have to remember. So if you are feeling something very gastric trouble in your stomach, you are going to add baking soda to your stomach. Then what happens? Soda acid, it is a mild antiseptic to our skins. Okay. Next is washing soda, what we use in our day to day life, that is how we are going to produce this washing soda. That means we have learned in the previous example, that is on reaction with baking soda on heating you are going to get this preparative method, that is washing soda or not? Yes. Na2CO3 you are going to get with water as an byproduct and CO2 as an byproduct. Now recrystallization of that you are going to get some water, and this is some preparative method. And if you take some uses, what are the uses is, so if you take some uses, you can write uses. Okay. Yes. So next one is uses. So this washing soda is been used in many cloth industries to remove dirt. Yes or no? It is used in removing dirt. That is, and also it is used to remove what? Permanent hardness of an water. Permanent hardness of an water. This you will learn in your future classes, your higher studies. Okay. The next is, it is also used as cleaning agent. Okay, like this. So take this as an example, that is NaOH. From these NaOH only you are going to get all this NaOH, CaOCl2, NaHCO3, Na2CO3 and all. So first you have to know their common names. After knowing their common names, you have to know their reactions, how they are reacting you have to know. After the reactions you have to know how they are being prepared. After their preparations you have to know their uses. So all this comes under your examination point of view only. So for and while take a screenshot of this, so that will be helpful for you. Take a screenshot and study comparatively. Comparative studies only better studies. Okay, you will not score good marks until and unless you compare and study. Compare such type of topics, or you may get more confused. Take a screenshot of this and study it very properly, the reactions and uses and the methods. Okay, next a simple topic, that is nothing but gypsum or plaster of Paris we are going to discuss now. Okay. So next is gypsum. So gypsum, which is also called as plaster of Paris, POP. So what is its preparation? So its common name is plaster of Paris, which is nothing but gypsum. Its preparative method, what you can say is CaSO4 on reacting with some water. If you heat it, what you are going to get? You are going to get CaSO4 half H2O plus, you are going to get some half water. So this is the preparation, or you can say a reaction of gypsum on heating. Okay, gypsum on heating, you can get this. So mostly doctors use what you can say that POP, that is to what you can say that your bones get fractured or broken, and what they use to be stable like this only, or to until and unless that bone gets recovered, before that time period they keep covering with plaster of Paris, and that blunt or dead plaster of Paris, you can say that plaster of Paris are dead blunt, dead burnt plaster of Paris, dead burnt plaster of Paris. Okay, so these plaster of Paris are nothing but dead and blunt plaster of Paris. These plaster of Paris are used as supporting agents. What they are used? They are used as supporting agents for your bones and fractured muscles and all. Okay, that muscles stay contacted with the bones, contact with bones by this covering only. After this covering has done, muscle gets contact with bones, and that muscle and bone contact after some days you may get recovered very fast only because of staying that bones muscles contact with bones. That stay is supported by this POP, that is nothing but gypsum, you can say. After that gypsum has been burnt, then you can say it as dead burnt plaster of Paris. Then you can say that gypsum as dead burnt gypsum plaster of Paris, and this gypsum is being added in cement, that is to increase initial setting. So this gypsum is being added in cement. Okay, cement you are adding some gypsum. Why? Because firstly some cement will be having some water, some mud and all, that this gypsum will act as some initiator or initial setter of that cement. So this gypsum is very important, and some points which are very important are nothing but it is also called as plaster of Paris, and this is reaction on heating. And at the same time, if that gypsum is being dead or burnt, then you can say it is as dead burnt POP, and gypsum is nothing but it is added in the cement as an initial setter. So all these points you have to remember starting from the end, and this whole chapter, all this point, water of crystallization also important. It is simple topic, and before that, starting from this acid, bases and salt, we have started with HCl is present in our stomach, which dilutes our food particles which are present in the stomach, and this by acids we can taste physically. If the taste sour in taste, then you can say it is nothing but by closing our eyes it is acid. If any compound is releasing H plus ions, closing our eyes you can say it is acid. If any acid having a pH scale between 1 to 7, then you can say it is acid. If any compound is accepting an electrons, you can say acid. So in this ways only you can determine acid or whether it is a base. Acids we can get from plants and minerals, yes or no? Then acids which is having below pH of 7, you can say strong acid. Strong acids are nothing but HCl and H2SO4, you can say. HCl is a very strong acid. Why you are saying very strong acids are means, I said you some theories, that is Arrhenius theory and Lewis theory. Arrhenius says that HCl is being reacted with completely ionized, it is giving H plus ion. When it is giving H plus ion, then you can say that is a very strong acid. Yes or no? Then next is Lewis acid. Compound is accepting an electron, then you can say it is Lewis acid. If the acceptor of electron, then you can say Lewis acid. Then next is coming to acid metal reaction. When acid is being reacted with metal, then it is going to produce some hydrogen type of molecules. That molecules you are going to get in that form. And this Na2CO3 on reaction with HCl gives rise to NaCl plus H2O. All these reactions are very important. Whereas coming to bases, they are bitter in taste and their pH is ranges from 7 to 14. At the same time, some strong bases are NaOH. How we are saying strong and all we have learned. And this NaOH is nothing but caustic soda, and complete ionization gives rise to NaOH. And NaCl is being, these are something what you can say, some basic knowledge how to, what you can say that NaCl is being formed as ions. That is nothing but NaCl gives rise to Na plus Cl minus. At the same time HCl gives rise to H plus Cl minus. How it is going to give also I have said you, the every topic keen, that is nothing but if chlorine is being reacted with Na plus, then what happens? Na loses one electron, it is going to get configuration of neon, argon, krypton, xenon and radon. At the same time HCl is being reacted and it is going to form H plus Cl minus. H2SO4 is going to form H plus and HSO4 minus. To divide that ions also very important, that you can learn in your further classes. Next is coming to NaOH, Arrhenius theory and all. And next is how you are going to determine strong acid, weak acid, strong base and weak base. Strong acid means complete ionization, HCl, H2SO4, weak acid means incomplete ionization, and strong base means complete ionization, weak base means incomplete ionization. This is also important. Indicator means acid, bases, indicator. What are the indicator? Where we are getting that indicator from? So indicators, if you take, they change in the color is nothing but you can see by your eyes, they are indicators. So by taking this one as a mechanism. So taking the indicators, how many types? Natural indicators, oil factory indicators, synthetic indicators and all. Natural indicators means the indicators which you get from nature, and the oil factory indicators, they are nothing but when the indicators are being recognized by our smell, then we can call them as oil factory indicators. If the indicators are being produced in the chemical laboratories, then we can call them as synthetic indicators, and then universal indicators. So all types of indicators, that is lichens and all. So litmus paper we are going to discuss, and we also discuss oil factory indicators. Then we discuss synthetic indicators, how they are and what are the examples of them. Phenolphthalein as an indicator, methyl orange is another type of synthetic indicator. They have been produced in the chemical laboratories. Okay. And next one is universal indicators, and next thing is mixture of acids and bases. What does acids and bases? If normally an acid which is in aqueous state only gives you an H plus ion, so that it is acid. If that is dry acid, it is not an acid, you can say that is because of it is not going to release H plus ions. If it is releasing H plus ion, then you can say them as acids. So next is pH scale ranging from 0 to 14. That pH scale is between, if the 7 is there as a middle point, 7 is nothing but a neutral point, 0 to 7 means it is ranges of acid, that is strength of acid, and these are the measurements. Taking an example, if there is 5.5 pH, then it is aerated water, you can say, and if there is a pH of 7.4, then blood pH is 7.4 only. If rainwater pH, if we calculate, it is nothing but 5.6. P stands for, P means potence, and it is been studied by a scientist Sorensen. Okay, next is pH in terms of mathematical terms. You can say pH is equals to minus log H plus, and minus log H plus means if there are H plus, there are 10 ions, you can say, you can replace minus log 10 ions, that means minus 1, log 10 means 1. Then is neutralization reaction. We have studied neutralization means what are the reaction that neutralizes. So acid plus base, that means acid on reaction with base, it neutralizes its effect. Okay, and it forms salt plus water. This is also most important to you. And next coming to acid reactions with metal oxide. This is nothing but an metal and oxide reacted with acid, and this is non-metal. Non-metal means CO2 reaction with base gives rise to CaCO3 H2O. Then common salt we have learned where we are getting from, what seawater and how its color is, and next impurities and all. Next coming to uses of salt, day to day life we are using, and next we have discussed the products and the bases what we are using day to day life. They are nothing but NaOH are very important, which we use. Bleaching powder we use, baking soda we use, washing soda also we use. These are the uses and preparation methods of them. And next coming to gypsum, this is also called as plaster of Paris, you can say. CaSO4 plus 2H2O gives rise to CaSO4 half H2O plus half H2O. And then next coming to it is if it is in dead burnt form, then it is called as dead burnt POP. Gypsum is added in cement as an initial indicator. With this chapter and with this up to your basics, we have cleared everything, and this screenshot is very much important. Take this screenshot and study comparatively. Only this topic something you may confuse in exam, revise it more times. Okay, so by this I am ending. Thank you one and all.